Okay, so welcome back. So I welcome all of you to this amazing platform of Tutee Learning. So we are live right now. I hope I'm audible to all of you. Welcome back. Okay, so again, I welcome all of you to this amazing platform of Tutee Learning. And today we're going to discuss with the lecture number 2 of coordinate geometry, right? So as of the last lecture, we have been discussing so far with the basic concepts on the questions regarding the concept of points or the distance formula, and also we looked into the concept of internal division of the line, right? So if you go back and check out the playlist in the previous lectures, you will be easily able to find those previous lectures. And today we're going to start with our discussion carrying forward on section formula. And before I do that, I have already listed some of the important properties that will help you to solve questions. Okay, so please take a note of these particular properties so that whenever any standard question is basically being asked on this particular topic, you can use these particular properties and relate to your questions. I hope that is clear to all of you. So with that part, let's start with today's discussion. Okay, so today we are going to discuss first of all how we do the section formula in case of external division. Okay, so section formula for external division. Okay, for external division. So section formula for external division is shown over here. Okay, so let us now try to understand what is first of all meant by this particular term, that is external division. So external division actually refers to that if I let us say that I have this as my line. So I have this is the two coordinates and the line is as follows. The line segment, I should be more careful on naming it. So AB is my line segment. And let us consider the coordinates of the point as x1, y1 and the coordinate of point B as x2, y2, right? So these are the coordinates of my point. Now, in the internal division, what we saw that if I want to get any point inside this line segment or inside this region of A to B, and if it is dividing in the ratio m is to n, then that particular thing was known as the internal division, right? So that particular thing is known as the internal division. So this particular part is the internal division, right? But today we'll discuss from the external division. What is meant by external division is that it is quite simple. Let us extrapolate this particular line. Then if I want to find out a coordinate of another point, let us say C dash, such that this particular point C dash is lying outside this region of A and B, but it is lying on the same line. Okay, I hope you are able to understand and correlate with a diagram over here. So if I want to know that point C dash, which is lying outside this particular region but on the same straight line, and in this case this particular distance ratio, maybe let us say it is n, and this particular distance is some given as m. Okay, so this is the ratio. Then I can say that the ratio of AC upon or AC dash upon BC dash is given as m upon n, is given as m upon n. Okay, so this is called as the external division. Now the formula for this is quite simple. We can easily get to the coordinate of C dash point by, so it will be just a replacement with respect to plus and minus. So here you can see that there is just a minus sign introduced over here. So the coordinates of point C dash is given as follows, like this. Okay, now please note that this particular thing exists only if, so this is possible if my m is not equal to n. Now in case of external division, m equal to n does not hold true. You cannot have a point C which is having the same distance from point A and point B in the real sense, right? So therefore m should not be equal to n. I hope this is clear to all of you. So this is a very important criteria to follow in case of external division. Okay, now again this particular formula or the coordinates can be derived like previously as that concept of the similarity of triangles. Okay, so we can use the similarity of triangle concept to come forward to this particular result. Okay, so please take a note on this, and If you have any question, please let me know, or else we can go forward with discussing on some of the relevant question, especially which is going to be very useful in order to understand the concepts of or the questions for JEE Mains. So let us try to solve one such question which is quite relevant, especially for JEE Mains. So try to solve this particular problem. Now these kinds of problems are quite a favorable problem, especially for JEE Mains examination. Okay, so please try to solve this problem. Please try to solve this problem. So please try to solve this problem. Now these kinds of problems are, if you can let me know the answer, that's great. And if you're not able to solve it, or maybe you're stuck, then I can discuss about the solution. Okay, quite a straightforward standard problem. Please try to solve this problem. Now these kinds of problems are, if you can let me know the answer, that's great. So alright, so I hope you have read the problem. If you look at this problem, it is said that if the point P divides this OA line internally in the ratio lambda 1 is to lambda 2, and the point Q divides this OA line externally, externally in the ratio lambda 1 is to lambda 2, then you have to prove that this OA is the harmonic mean of OP and OQ, right? So this kind of question can be asked in JEE Mains, as it might not ask you to prove. It might say that then OA is the dash of OP and OQ. So they will give you three options: arithmetic mean, geometric mean, harmonic mean, and none of the above. So that kind of question is quite a favorable question for JEE Mains paper. So let's try to understand these kinds of problems. Okay, I know this is quite a simple problem, but yet it is an important problem. So if I try to represent this O and this A point somewhere over here, okay, and what I see is that P point is divided internally in the ratio lambda 1 is to lambda 2, and this Q point is divided in its external division. So this is the external point, and it is again dividing the line OA in the same ratio lambda 1 is to lambda 2. So maybe I have to shift this lambda, maybe because I am writing with respect to lambda 1 is to lambda 2, or let us write like lambda 1 is to lambda 2, that means OP by PA, and in a similar sense then if I have to write like that, in the similar sense, this particular ratio should also be lambda 1 and lambda 2, right? That is what is mentioned in the problem. So if I do that, so let us first of all try to find out this OP point. Okay, so if I try to find out this OP point, so OP will be, so if I try to find out the OP by OA, so that is going to be, so that is going to be lambda 1 times of lambda 1 times of, or lambda 1 divided by lambda 1 plus lambda 2, lambda 1 by lambda 1 plus lambda 2. So from here, what I can comment is that then 1 upon OP is equals to lambda 1 plus lambda 2 divided by lambda 1 times OA. Right, I can write this particular relation. So I can easily write this particular relation over here. Right. In a similar sense, if I do for the external division, then I can write 1 upon OP for external division as lambda 1 minus lambda 2 by lambda 1, and that will be times of OA. Right. So in the similar sense, I can write for 1 upon OP, right? Because this particular ratio is again lambda 2, and this particular ratio is lambda 1. So this particular length should be lambda 1 minus lambda lambda 1 minus lambda 2, this particular length, right? So PA length will be given from that. So I can write, oh sorry, it will be just a Q over here, right? Q 1 upon OQ, right? This particular length 1 upon OQ, right? So this can be given as follows over here. Now what I can do is that if I consider this is my first equation and this is my second equation, now if I add both the equation, if I add equation 1 and equation 2, what I will get? So if I add equation 1 and equation 2, what will I get? So 1 upon lambda 1 times OA will be common, and I will have lambda 1 plus lambda 2 plus lambda 1 minus lambda 2. So this part will cancel out, and I will be having 1 by 2 by, sorry, I will be having I'll be having 2 upon OA. So what I can see is that 1 upon OP plus 1 upon OQ is equal to 2 times of OA, which is nothing but I can write the same thing as OA is the harmonic mean of OP and OQ. So is the harmonic mean of OM, OP and OQ. So therefore from here I can simply come to this conclusion by simply finding out this ratio over here. Okay, the sum of these two ratios. I hope this is clear to all of you. I hope this particular part is clear to all of you. Just let me know in the live chat, is this part clear? So therefore from here, is this part clear to all of you? Please let me know in the live chat, is this part clear or not? The sum of these two ratios. I hope this is clear to all of you. I hope this particular part is clear to all of you. Just let me know in the live chat, is this part clear? So therefore from here, is this part clear to all of you? Please let me know in the live chat, is this part clear or not? The sum of these two ratios. I hope this is clear to all of you. I hope this particular part is clear to all of you. Just let me know in the live chat, is this part clear? Okay, so I hope this question is clear. And with this, let us move to another important problem. And this problem is quite an interesting problem. So please try to solve this problem. So okay, so I hope this please try to solve this problem. And it's a quite interesting problem. Okay, please try to first of all read the problem carefully and then you try to solve the problem. Okay, so please go through the problem and then try to solve it. Okay, please try to solve it. Don't get frustrated. This will be quite a lengthy, like a repetitive steps will be there, right? So if you read through the problem, you will see that first you're taking the ratio as 1:2. First you're taking the ratio as 1:1. Then you're taking the ratio as 1:2. Then you're taking the ratio as 1:3, 1:4, and so on, right? Till there, n points are exhausted, right? So therefore, you have to find out the coordinate of the final point so far obtained, right? And this is a very interesting result that you will get, and you can also keep that particular result in your mind, right? So this kind of question can be a interesting geometrical problem, especially for all of you, right? N points are exhausted, right? So therefore you have to find. So please take a note of this problem. Final point so far obtained. Please try to solve this problem. Very interesting result that you will get, and you can also keep that particular result in your mind, right? So this kind of question can be okay. Please take your time and try to solve this problem for all of you, right? N points are exhausted, right? So therefore you have to find. So please take a note of this problem. Final point so far obtained. Please try to solve this problem. Very interesting result that you will get, and you can also keep that particular result in your mind, right? I hope I'm audible, right? Okay. Yeah, great. So please solve this problem and let me know the answer. Please solve this problem and let me know the answers. Please let me know the answer you are getting. I hope I'm audible, right? Yeah, great. So please solve this problem and let me know the answer. Please solve this problem and let me know the answers. Go forward with the solution, right? Please let me know the answer you are getting. I hope you have read the problem. So if you read the problem carefully, what is mentioned is that they have given some n number of points in a plane whose coordinates are also given something like xi comma yi, right? Now it is said that a1 a2 is bisected at the point p1. P1A3 is divided in the ratio 1:2. P2P4 and P2, P2A4 is divided in the ratio 1:3, and so on, such that unless and until the end point are exhausted, right? So that is the main problem, right, at P4 and so on. So you have to find out the coordinate of the final position. So if I start as A1, A2 is bisected, so A1, if I draw like A2, so the point P1 is the bisector of A1, A2, so that is the midpoint. So I can easily obtain the coordinate of point P1 would be simply given as x1, x1 plus x2 by 2, comma y1 plus y2 by 2, right? This is going to be the coordinate of point P1, and similarly this P1 and the line P1A3 is divided in the ratio 1:2, right? So therefore from here I can utilize the coordinate of P2, or the P2 point divides this P1 A3 and P1 in the ratio. So the obtained line like this. So we have A3 over here, and this P1 and A3 is divided in the ratio 1:2 somewhere by point P2. So therefore, I can obtain the coordinate of P2 as follows. That will be 2 times of 1 plus x1 plus x2 by 2 whole divided by 3 plus of x3, comma 2 times of comma 2 times of again y1 plus y2 by 2 plus y3 whole divided by 3. So what you can obtain is that it is quite a straightforward, that is going to come out as x1 by plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3, right? So this is going to be the coordinate of point P2. In a similar manner, if you consider point P2 and then you consider the A4 and P1 A4, right? So let us say this is P1, okay, right? This is P1 and A4, and similarly you want to find out the point P3, which is again dividing the ratio 1:3. Again the ratio 1:3, right? In this case, you will obtain the coordinate of P3 will be coming out something like x1 plus x2 plus x3 by 4, comma similarly you want to find out the point P3, which is again y1 plus y2 plus y3 plus y4 by 4, you will obtain the right. So if you perform this step so on such that n points are exhausted, that will be the nth steps, right? So if you do that, you can see it is quite simple. It's just the addition of all the coordinates divided by the nth point, right? Plus y3 plus y4 by 4, right? So is this part clear? Divided by the n plus 1th point, right? N plus 1th point. So similarly, if you proceed in this manner, the final point that is which is dividing P1 and A of n will be given something like P of n, right? Which is again the ratio 1:n, and this particular coordinate is given. But just to be careful, it should be P of n minus 1, P of n minus 1, because when you have P1 A4, it is coming at P3. Similarly, P1 AN should be P of n minus 1. So the coordinate of P of n minus 1 should be given as x1 plus x2 up to xn by n, comma n minus 1, P of n minus 1, because when you have y1 plus y2 and so on up to y of n divided by n, right? So this is going to be the final coordinate of that particular final point. I hope this question is clear. It is quite a tricky problem, but quite an interesting problem. Okay, so it's kind of a pattern matching problems. Okay, now these kinds of problems are quite an useful problem, especially for your JEE Mains examination. So this is going to be the okay. I hope this problem is clear. So now let us quickly go forward discussing about some of the important points or the coordinates of the triangle. Like, let us first of all discuss about the centroid of a triangle. So, if I have to talk about what is a centroid of the triangle, so the definition can be followed from here. So the centroid of a triangle is defined as the point of concurrency of the medians, right? So it is the point of intersection of the medians of any triangle. It is called as a centroid of that particular triangle. So if I take a triangle with the following vertices as the coordinates, then the position of the centroid would be given as sum of the points divided by 3, right? Sum of the x coordinate by 3 and sum of the y coordinate by 3. So how can we come to this result? It is quite a simple algebra or relation from the understanding of our geometry, right? So if I take up any triangle like this, let us say this is point A, which is given as x1 comma y1, my point B, which is given as x2 comma y2, and my point C, which is given as y3 comma x3, right? So if I draw the medians at this particular point D, now we have seen that the centroid, if we have already seen this particular in our previous geometrical classes, so maybe in your junior classes when you learnt about triangles, you have already seen that the centroid divides the median in the ratio 2:1. So if it is the centroid and this is my point A and this is my median point, that is going to be D over here, right? So that is given as 2 is to, that is given in the ratio 2 is to 1, right? And also the D point is nothing but the midpoint of BC. So the coordinate of D, would be obtained as x2 plus x2 plus x3 by 2 and comma y2 plus y3 by 2, right? That will be the coordinate of point D. Now if you do the section formula over here and you try to find out the coordinate of point G, you will see that the result will be going to come out something like this. So which is basically we did in the problem previously, right? So if you check it out, you will see that this particular result is going to come out. I hope this is clear to all of you. I hope this result is clear to all of you. Now, if you do the section formula over here and you try to find out the coordinate of point, so in the similar notation, let us try to discuss about the concept of in-centers. Okay, so let us quickly discuss about the n-center. So again, in a similar manner, if I recall the definition of in-center, which is quite a straightforward definition, and we know that in-center is nothing but the point of concurrency of the internal angle bisector. So they are the internal angle bisector point of intersections of a triangle is called as the in-center. And in case if you have an external angle bisector, then that is called as the x-center. So again, the coordinate of that in-center is given something by this particular formula. So if you are curious enough to know how this particular formula comes up, I can give you a bit of a hint. However, I won't derive the entire formula myself. Okay, so I leave some of the part to you to derive and let me know the answer or whether you are able to get to this particular result or not. So that I leave up to you, right? However, I would definitely love to give you a glimpse of that formula, right? So if I consider, this is my triangle A, B and C. Now the side opposite to vertex A is given by the length of A, right? So the side length of BC is A. The side length of AC would be just B because that is opposite to the vertex capital B, and the side length of AB will be given as C. This is my triangle. Okay. So if I have this, now in-center is the centroid of the circle or the in-circle that is inscribed inside the triangle. So that is the center point of this circle, right? Also, it is the angle bisector. So if I draw the angle bisector of the three vertices of the triangle, so this particular angle is going to be B by 2, B by 2, this particular angle is going to be A by 2 and so on, right? This particular angle is going to be C by 2. Now, again relating with the geometry thing, since let us consider this particular line point as AL, this is M and this is N, right? This particular vertexes. So what I can find out that let us consider this following coordinates, then we have already seen by the interior angle bisector theorem, that is, if I have any triangle like this, and if AL is my internal angle bisector, then I have this particular formula, that is AB upon AC is going to be equal to BL upon LC, right? So this is a very important formula that we will use this in our solution. So that will be equals to C upon B. So BL by AL LC is going to be equal to C upon B. So we have from here we'll get the division or the ratio, right? So if I try to from this particular relation, what I do, I do kind of a modification to this result, that is LC upon BL plus of 1 is equals to B upon C plus 1, and this particular result can be further modified. So LC plus BL is going to be BC upon BL, and that is going to come out as B plus C upon C, right? Now BC is nothing but A, so A upon BL is going to come out as B plus C divided by C. So from here what I can come out is that BL would be AC upon B plus C, right? So BL will obtain the relation of BL, that is going to be AC upon B plus C, right? So that is going to be AC upon B plus C. So what I can say is that point L divides the line segment BC in this following ratio. So from here, what I can come out is that BL, if this is my point B and this is my point C and this is my point L, I have obtained this particular line, right? And the remaining, this particular relation can be obtained by subtracting it from A minus AC upon A plus, sorry, B plus C, right? L divides the line segment BC in this following ratio. So that will come out to be AB upon B plus C. So this is the ratio. So we have obtained the ratio of BL upon CL, that is nothing but again the same as C upon B, right, which you have already seen. Now from this particular relation, and the similarly if we apply for the other coordinates, you will similarly obtain the same relation, that is follows as, so I will also obtain AL is to IL, right? So I is my incenter, and this particular relation I can obtain by the other internal angle bisector. So AL by IL is going to be equal to AB upon BL, and that will be equal to C upon AC by B plus C, right? Which I am relating from this interior another triangle, from this particular triangle, right? And this particular relation I can obtain, that is AL, this particular length AL upon IL, right? So AL, this particular length upon IL is equals to AB upon BL, right? So by this particular triangle, which I can draw with a blue color, this particular triangle. Okay, so from this we will be obtaining the following relation of AL is to IL. So if you know the section formula, and then you can try to find out the coordinate of point I, right? So you know the coordinate of point L, you know the coordinate of point I, right? So from that you will get the coordinate of point I, and if you just carry forward this particular few lines of algebra, you will definitely going to come up or end up getting this particular result as follows over here. So if you know the section formula, and then you can try this particular result, the coordinate of, you will be easily able to get it, right? So okay, you know the coordinate of point L, you know the coordinate of point. Is this part clear to all of you? From that you will get the coordinate of point. Is this part clear? If you just carry forward this particular few lines, just let me know in the live chat, is this part clear or not? Definitely going to come up or end up getting this particular. So in the similar manner, we can also obtain the excenters, right? So in the similar manner we can obtain the excenter. So I am just showing one of the excenter. So let us say, and also if you want to know what is the excenter of point A, so again if I draw the same triangle, if I draw this triangle, let us say this is my point A, B and C. Now the excenter is, you will have one angle bisector, one interior angle bisector, and the remaining you will have the external angle bisector. So for example, if I want to know the excenter corresponding to vertex A, because for excenter you will have three excenters, right? So if I want to know the excenter corresponding to vertex A, I will take the internal angle bisector of vertex A, and I will take the external angle bisector of vertex B and C as follows, right? And this is going to be my excenter, which I can denote by I1. And the result for I1 is quite and simple. It is going to be minus AX1 plus BX2 plus CX3 divided by minus A plus B plus C. This is going to be the X coordinate. And in the similar manner, we can obtain the Y coordinate as minus AY1 plus by2 plus cy3 whole divided by minus a plus b plus c. Okay, so in the similar manner you can obtain the relation for I1 and I2 and I3, right? So in case of I2, the b coordinate will be a negative, and in case of I3, so this is I3, the c coordinate will be negative, the c part will be negative, right? So please do the calculations over here and you will be easily able to get to this solutions. And in the similar sense, if I show you the derivation for circumcenter, now we saw the derivation for incenter, right? So the circumcenter derivation is related to the solution of triangles, right? So in your trigonometry classes, you must have come across this derivation. So maybe if you haven't done the derivation of a circumcenter of a triangle, don't worry, I am definitely going to cover that particular derivation. However, for this particular scope of the chapter of coordinate geometry, I'm not going to cover this, right? But this is quite a very standard result, okay? It is a quite a standard result, and we can easily derive this particular result of circumcenter or the coordinates of circumcenter. Okay, so there is a geometrical thing that is related to it. Okay, so maybe we will discuss this part in the chapter of solution of triangles, right? But for the time being, what you can do is that you can just remember this particular result. Okay, you can just remember this particular result, and the similar manner for the orthocenter also. You can, for the time being, you can remember the result, right? However, if you are curious about that, what happens if I don't know the angle? Should I always calculate the angle? No. If you are already given, maybe the equation of the lines of the triangles are given to you, which I will be discussing in the upcoming topics of straight lines. So if you have the equation of one of the line and you know how the coordinates, maybe by that particular line equation you can easily calculate the circumcenter and the orthocenter. Just it is quite important to know the basic definition. Orthocenter is a point of concurrency of the altitudes of a triangle, and circumcenter is the point which is equidistant from all the vertices. That is the circumcenter, right? So if you recall or if you know this particular definitions, then I think you are probably in a good place to derive or come out with the solution. But for the time being, you can remember this particular part. In case you are given the angle of the triangles and the coordinates, you can easily come across, or maybe if the angle is not given, with the coordinates also you can find out the angles, and from that angles you can definitely find out for the points on the or the coordinates of the following points, like the circumcenter, orthocenter, incenter, excenter, and all those questions. Okay, so with this part I think it is quite clear. Now we are almost done with our discussion on the chapter of coordinate geometry basics part, right? So the upcoming lectures is going to definitely come on the concept of straight line. Okay, so we are going to soon start with our discussion on straight lines. Okay, so the straight line concept is going to be coming up live very soon. In the next class we're going to start with the formulation of the equation of straight line, and following that we're going to look into the properties, right? Because equation of straight line is quite a straight, writing the equation of straight line is a quite important property that you need to learn up, right? So with this particular part I think you are pretty much good to go with the basic portion. So maybe I will try to give you some problems to solve, right? So maybe I will give you some homework problems. So please try to solve these problems as a homework problem. Okay, so please take a screenshot of this and try to solve this problem as a homework problem. Okay, so please solve this problem as a homework problem. Okay, from question number 10 to question number 15. So there will be 5 problems as a homework problem. So please solve this problem and comment the answers below as after the live is over. Okay, I hope this is clear to all of you. So with this, thank you and I wish you all the best. As a homework problem. Okay, so please solve this problem as a homework problem. Okay, from question number 10 to I hope this is clear to all of you. So with this, thank you and I wish you all the best. And